Subject of electric circuits. In last lecture, we have discussed the statement of maximum power transfer theorem. The statement was that the maximum amount of power will be delivered to the load resistance. This was your statement, that maximum amount of power will be delivered to the load resistance when the load resistance is equal to the Thevenin's resistance of the network supplying the power. That means if RL is equals to RTh is the condition, then and then only the maximum power will be transferred to the load resistance. That means the value of load resistance should be equal to Thevenin's resistance. लोड रेजिस्टन्स RL ची व्हॅल्यू जर थेवेनिन्स रेजिस्टन्सच्या इक्वल असेल तर आणि तरच मॅक्सिमम पॉवर लोड रेजिस्टन्सला ट्रान्सफर होईल, डिलिव्हर होईल, असा हा मॅक्सिमम पॉवर ट्रान्सफर थिअरम सांगतो. पण जर लोड रेजिस्टन्सची व्हॅल्यू थेवेनिन्स रेजिस्टन्स पेक्षा कमी असेल और ती थेवेनिन्स रेजिस्टन्स पेक्षा जास्त असेल तर काय होईल? या सेकंड पॉइंट मध्ये दिलं होतं आपल्याला की जर लोड रेजिस्टन्सची व्हॅल्यू ही थेवेनिन्स पेक्षा कमी किंवा जास्त असेल, ह्या दोन्ही कंडिशन मध्ये जी पॉवर लोडला डिलिव्हर होणार आहे तिची व्हॅल्यू ही लेस दॅन मॅक्सिमम व्हॅल्यू असेल. व्हॉटेवर मॅक्सिमम व्हॅल्यू विच वी शुड गेट ॲट द लोड रेजिस्टन्स विल बी हॅव्हिंग लेस व्हॅल्यू इफ द लोड रेजिस्टन्स RL is less than or greater than Thevenin's resistance. So this was the main statement of the maximum power transfer theorem. This one, maximum amount of power, this is the main statement. And this was the condition that what happens when lower or higher value is occurring. So after that we have derived the condition for maximum power transfer. This is a figure of Thevenin's resistance, and we have to prove that RL is equals to RTh. We have to prove it that RL is equals to RTh. So to prove that, this was a proof. To obtain maximum power transfer theorem, we have to refer this circuit. Okay, and the load power formula here is PL is equals to IL square RL. To obtain RL is equals to RTh, we have to rearrange this formula in such a manner that we have to put the value of IL square here. Okay, so from figure we have said that RL is the load resistance, and that load can be anything. For example, your electric heater, electric bulb or electric motor. These types of loads are called as loads. Okay, heater may be resistive load, bulb is also resistive load, motor may contain RL load, RC load or RLC load. तिन्हीपैकी कुठलाही लोड मोटर मध्ये असू शकतो. मोटर ही कधीच प्युअर रेजिस्टन्स लोडला ऍक्ट होत नसते. हीटर मात्र तुमचा प्युअर रेजिस्टिव्ह लोड आहे, बल्ब सुद्धा तुमचा प्युअर रेजिस्टिव्ह लोड आहे. सो RL इज योर लोड रेजिस्टन्स, आणि तो कुठलाही लोड असू शकतो. मग आपण थेवेनिन्स सर्किट रेफर केलं होतं हे बरोबर. थेवेनिन्स सर्किट मध्ये करंट I चा फॉर्म्युला काय बघत होतो आपण? VOC डिवाइड बाय RTh प्लस RL. सेम फॉर्म्युला घेतला, त्या I ला फक्त मी IL म्हणलं, लोड करंट म्हटला. IL इज इक्वल्स टू VOC डिवाइडेड बाय RTh प्लस RL. मग ही IL ची व्हॅल्यू, जो फॉर्म्युला आपण आता लोड पॉवरचा बघितला होता, IL स्क्वेअर RL मध्ये ठेवल्यानंतर त्याचं सोल्युशन असं येईल. मग नंतर त्याला डिफरन्शिएट केलं, डिफरन्शिएट करून डिफरन्शिएशन डेरिव्हेटिव्ह घेतला, दिस डेरिव्हेटिव्ह वी हॅव इक्वेटेड विथ 0. सो we have derived this P by RL formula. We have derived this value VOC square RTh plus RL into RL. So after solving this derivation, I got the condition that RTh is equals to RL. म्हणजे मला जे प्रूव्ह करायचं होतं, whatever I wanted to prove that RTh is equals to RL, that has been proved here. Give this as equation number 1. And this is the condition for maximum power transfer. So till this point we have covered in last lecture. In today's lecture we are going to see what is the value of maximum power, how to calculate the maximum power. If RL is equals to RTH is the condition, then how to calculate the maximum power? For that we have to also see the formula. Similarly, what are the stepwise procedure to solve the maximum power transfer theorem, and what are the applications of the maximum power transfer theorem? So these 3 points we are going to cover up in today's lecture. Okay, so now in last lecture also and now also we have revised that how the condition RTH is equals to RL is derived, and when RTH is equals to RL, that is Thevenin's resistance is equals to load resistance, then of course maximum power will be delivered to the load resistance. So we have to calculate that maximum power, and to calculate that maximum power, first of all we should know the current through the load. We should know current through the load, and that current through the load, that is IL is equals to VOC divided by RTH plus RL. Okay, this is your formula for current. But condition काय है? What is the condition? RTH is equals to RL. So I will replace this RTH by RL. So this becomes RL plus RL is equals to 2RL. RL plus RL is equals to 2RL. How this RL is taken? By this condition. RL is equals to RTH. RL is equals to RTH. So the value of current I am getting is VOC divided by 2RL. Okay, आलं लक्षात current कसं आलं? Now we have to find out the maximum power delivered. Maximum power delivered. And we know the formula for load power is IL square RL. IL square RL. Put the value of IL in this formula, that is VOC by 2RL. ही value put up करायची आपल्याला IL च्या ठिकाणी. ओके, ही ठेवायची. ही ठेवल्यानंतर काय होतं? VOC डिवाइड बाय 2RL होल स्क्वेअर. IL स्क्वेअर आहे ना, सो याचा स्क्वेअर घेतला इंटू RL. सो दिस इज VOC स्क्वेअर डिवाइड बाय 4RL स्क्वेअर. RL स्क्वेअर म्हणजे काय? RL इंटू RL. Your RL square is nothing but RL into RL. Okay, that means one RL will get cancelled with this RL, and the maximum power formula we are getting is VOC square divided by 4RL. Means if a numerical is asked in such a manner that calculate the maximum power flowing through a particular branch or through a given circuit using maximum power transfer theorem, then to calculate the maximum power we have to use formula this VOC square divided by 4RL. Give this as equation number 2. But keep in mind, whatever maximum power we are calculating here is actually 50% of the power supplied by the source. सोर्स जेवढा पॉवर सप्लाय करतोय तेवढी सगळी पॉवर आपल्याला लोड साइडला मिळत नसते. तर ती जी मॅक्सिमम पॉवर आपण कॅल्क्युलेट करतोय दॅट इज ऍक्च्युअली 50% ऑफ द सोर्स पॉवर. जे काही व्होल्टेज सोर्स, करंट सोर्स आपण वापरतोय त्या सोर्सची जी काही पॉवर ची व्हॅल्यू असेल त्या पॉवर व्हॅल्यूच्या 50% व्हॅल्यू ही आपल्याला लोड साइडला मॅक्सिमम पॉवर म्हणून मिळते. That means even though the condition of maximum power is satisfied, only 50% of power is delivered to the load. भले इथे तुम्हाला मॅक्सिमम पॉवरची कंडिशन सॅटिस्फाय झालेली दिसते, पण प्रॅक्टिकली जर आपण बघायला गेलो, प्रॅक्टिकली ती पॉवर ओनली 50% आहे. प्रॅक्टिकली ती जी काही पॉवर लोडला डिलिव्हर झालेली, ट्रान्सफर झालेली ती 50% पॉवर आहे. मग राहिलेली 50% पॉवर कुठे जाते? वेअर इज द रिमेनिंग 50% पॉवर इज wasted. That 50% power, remaining 50% power is lost in the Thevenin's resistance. Is lost in Thevenin's resistance. Of course, resistance will lose the power in the form of heat. We have learned this concept initially. That means whatever 50% power we are getting at the load side, we call that 50% power as maximum power, and remaining 50% power is lost in the Thevenin's resistance in the form of heat. In the form of heat. So keep in mind this point, you have to keep in mind. Okay. So this was the value of maximum power. Now next point is stepwise procedure to solve the given circuit using maximum power transfer theorem. In short, it is called MPT theorem. It is called MPT theorem. So in MPT theorem, what are the steps to solve the numerical? So see, first step is obtain VOC and RTH as we are calculating in the Thevenin's theorem. Thevenin's theorem मध्ये जसं आपण VOC आणि RTH कॅल्क्युलेट करत होतो, सेम त्याच पद्धतीने तुम्हाला ओपन सर्किट व्होल्टेज आणि Thevenin's equivalent resistance calculate करायचा आहे. Then obtain the value of RL is equals to RTH for maximum transfer of power. Then we have to see the fulfill the condition that whether your load resistance RL is having the value equal to the Thevenin's resistance. Thevenin's च्या equivalent त्याची व्हॅल्यू आली का नाही हे चेक करायचं आपल्याला. Then and then only maximum power transfer is possible. And then after checking this condition, we have to calculate the maximum power at the load resistance. Maximum power at the load resistance. Just these are the three simple steps to solve the MPT. And the first step is already we have learnt in the concept of Thevenin's theorem. So we can find out what is the open circuit voltage and Thevenin's resistance. So this was the stepwise procedure. The next and the last point for the MPT theorem is the application. Application of the MPT is in the power amplifier. Okay, how it is applied in the power amplifier? Why it is used in the power amplifier? To match the loudspeaker impedance to the output impedance of the amplifier in order to ensure maximum power transfer. Whatever we are speaking on the mic, if in the public meeting it is not heard properly, then we cannot say that we have conveyed a right message to the public. And hence in power amplifiers we use amplifiers for that purpose, to reach the voice, to send our voice to the last audience of the hall, to the last audience of that open ground. We use the power amplifiers, and these amplifiers will amplify your voice when the loudspeaker impedance is equal to the output impedance of the amplifier. लाउडस्पीकरचा इम्पेडन्स आणि एम्प्लिफायरचा आउटपुट इम्पेडन्स हे जर इक्वल झाले तर आपल्याला क्लिअरली मागे आवाज ऐकू येतो. ओके, म्हणून बघा एम्प्लिफायरचे तिथे एम्प्लिफायर बॉक्स इज देअर and knobs are provided to the amplifier so that voice is clearly reached till last audience. So from that knob we are adjusting the output impedance of amplifier. We are adjusting the output impedance of the amplifier. And also the second application for MPT is impedance matching in any electrical circuit. See, in any electrical circuit, impedance is the most important factor. Impedance is nothing but Z is equals to R plus XL. R plus JXL, I will say Z is equals to R plus JXL, or Z is equals to under root R square plus X square, where R is resistance, X is reactance and Z is impedance. We have learned the concept of impedance initially. So in any electrical circuit, it is very important to match the impedance of the circuit. If impedance matching is not possible, then that circuit cannot be coupled electrically to the other circuit. Now electrically coupling means what? Impedance matching, okay, frequency same आहे, voltage same आहे, current same आहे, पण तुमचा impedance जर match होत नसेल तर मात्र मग parallel operation of transformer is not possible, parallel operation of generator is not possible, parallel operation of alternator is not possible. Okay, parallel operation means what? Load sharing. For example, 3 persons are working on work. Suddenly one person gets sick. 3 लोक काम करत आहेत, 3 पैकी एक आजारी पडलाय. मग काय करणार? दोघं त्याचं लोड शेअरिंग करणार की नाही? पण कसं करणार? त्यांची जर तेवढी कॅपॅसिटी असेल काम करण्याची तरच लोड शेअरिंग करू शकतात ना. तर कॅपॅसिटी नसताना जर एखादा माणूस काम करायला लागला तो दुसरा माणूस आजारी पडेल, मग सगळं एकावरच लोड पडेल. Right? If the second person is not that much efficient, he cannot share the load of the third person with first person. So what will happen? That second person will also become ill, sick. Then all the load will come on the first person. So of course, if one person is doing the work of 2 persons, then the capacity is of course not that much efficient. That is for every person. That is for every person, not for me and you. That is for every person. Hence, what we do, if one person is ill, then that 2 persons, I will check that 2 persons are having the same capacity, or they are having the capacity to complete the work in the provided days. Okay, in similar manner in electrical circuit, the impedance matching is also needed, and hence to match the impedance of a given electrical circuit with the other electrical circuit, maximum power transfer theorem can be applied. So if you see till now, Norton's theorem, MPT theorem, these both theorems, these 2 theorems are dependent on the Thevenin's theorem. Are dependent on Thevenin's theorem. How they are dependent on the Thevenin's theorem? See the first step in the MPT theorem, obtain VOC and RTH. Okay, obtain VOC and RTH. Here in MPT, in Norton's theorem, if you remember, first step is calculate short circuit current, and in second step we are calculating the Thevenin's resistance or Norton's resistance. RTH or RN we are going to calculate there. That means in Thevenin's we were calculating open circuit voltage and Thevenin's resistance. In Norton's theorem we are calculating short circuit current and Thevenin's resistance. In MPT we are calculating open circuit voltage and Thevenin's resistance. So these are the 2 theorems which are having the base of Thevenin's theorem. Hence, Thevenin's theorem is the most important theorem in the network analysis, because on the Thevenin's theorem, both the theorems of MPPT, that is maximum power transfer theorem, and Norton's theorem is dependent. Okay, so we will stop here. In next lecture we will discuss the numericals on the MPPT theorem, and then after numericals we will discuss the point of reciprocity theorem, and then after reciprocity, numerical on reciprocity, and the last point after reciprocity will be duality of a network. Duality we have to study duality principle, and I think so reciprocity are not in the syllabus of the electronics students, but then also we will study for it, because it is very easy theorem, reciprocity and duality theorem, most easiest theorem in the network analysis. Okay, so we will study that 2 points after completing the numerical on empathy. And of course in the tutorial lecture I will provide you the all the numericals on the particular point. First of all, again I will start from the superposition theorem, then we will discuss Thevenin's theorem, then we will discuss Norton's, then we will discuss the empathy, and then reciprocity and duality. Because since last lecture, as I was busy with some work, so I will again start your numericals from superposition theorem. Till then we will stop here. Thank you.